exponents. Okay? Exponents exponents are what we just finished talking about, right? We just took our tests on them. We did decent on them. Exponents and logarithms are very, very closely related. Okay? Very closely related. Sorry. Maybe. Oh, okay. So what I need you to understand about exponents and logarithms, I'll tell you the word in just a second. It's enough right now to know that they're closely related. Okay? So let's kind of work to get there. All right? Is there a way to solve 2 to the x power equals 20 algebraically? Okay? You can solve it by guessing, you can solve it by using a table, and you can solve it by graphing, but this class is actually called algebra, so we'd actually like to know if there's an algebraic way to do it. Okay? We need a way to undo exponents, just like we undo other operations. What if we're adding 4? Well, it looks like this. N plus 4 equals A, right? How do we just solve for n? We subtract 4 from both sides, right? And we get A minus 4. So we undid the adding 4 by subtracting 4. Does that make sense? Okay. What about multiplying by 3? It looks like 3n equals A. How do we solve for n? Divide both sides by 3. So it looks like A over 3. How do we undo it? What did we do? Good. Divide by 3. Okay? What is happening here? What's happening to the n? It's squared, right? Or we're squaring the n. How do we get the n by itself? Square root. So it ends up looking like the square root of a, and we undid squaring something, or something squared, by taking the square root. So what about exponent? Where is the n? It's in the exponent, right? And that's part of the problem, because we don't know how to get the n out of the exponent until today. Dun dun dun. This is what it looks like. Sorry, that's a 2. Log base 2 of a. I am. Mr. Neal came in and hooked up a microphone to my projector. So right here, there's a microphone. So sometimes I still use my headphones because sometimes this is kind of fuzzy. But I figured I'd try it again and see if it's any better. But thank you for making sure. Okay? So the way that we undo exponents is to use logarithms. Okay? And this is the unit we're starting today. Just to give you a heads up, next Friday is the end of the 6 weeks, right? You know that? Next Friday is the end of the 6 weeks. We take our test on this unit on Thursday. Okay? We're going to spend basically a week-ish on this unit. Okay? It's actually a little bit more than a week, but normally we do all the stuff, and I usually have about a day or so to talk about where it's used outside of my classroom, right? I can give you word problems and stuff before then, but we usually only get to take a day to talk about the application. With logarithms, we're going to take 2 days. Is it because it's that hard? No, it's because there's a lot of places logarithms are used, and you don't even realize it. You know a lot of it, but you don't even realize logarithms are being used. Okay? So we're going to take 2 days and talk about that. We'll take 2 days, and well, today we're talking about I'm introducing logarithms to you. Tomorrow we're going to talk about graphing the logarithms. Thursday we're going to talk about some more properties of logarithms so that we can, on Friday, solve equations with logarithms. Monday we will review that. We will go over it again. So we're basically going to spend 2 days on solving logarithms. Okay? And then 2 days on applications, and then it's time for the test. All right? So after this past test, some of you are in a really good place as far as your average goes. Some of you have 2 weeks. Okay? All right, so let's look at this. What does the graph of a logarithmic function look like? Well, what's this graph? What does that look like? Yeah, it's increasing. It's exponential like we just did, isn't it? Okay? And here's the table that it came from. Well, exponential and logarithmic functions are inverses. Remember I told you a minute ago they're super closely related? This is how closely they are related. One, you can get one from the other, right? How do we get one from the other? How could we generate the logarithmic graph? Switch what? How about if I spell it right? S-W-I-T. Switch x and y. Good. Switch x and y. So if I have a table already of an exponential function, could I find a table of a logarithmic function? How? Switch x and y. Let's do it. After I switch x and y, I'm going to go ahead and plot the points. I would like you to do that as well. Okay, so what line did I just draw? It's y equals x, right? Okay, this line that I just drew is y equals x. And the reason it's y, why did I put that on there? Why do we care? Doesn't this show me that this is truly a inverse function? Because if I folded my paper on this line, what would I see? A reflection, right? It's reflected over that line y equals x. If I folded it, those two functions would be right on top of each other, wouldn't they? Okay? So exponential looks like this, right? Just a parent function exponential. But this is what a parent function logarithmic function looks like. Okay? So here's the meat of the matter. Okay? Here's the really important part of today's lesson. Not that the rest of it's not important, but you know what I'm saying. Okay? How do you write and read logarithms? What do their symbols look like? Okay? If b to the x power equals a, then we got to fill this in. Okay? This right here is called exponential form. Why? Because it's an exponential form, right? There's exponents here and stuff. Okay? What is this thing right here called? An exponent, right? So what's this called? The base. Very good. Okay? Well, that value, whatever that value is, actually goes right here when we're writing in logarithmic form. Guess what it's called right here? A base. So the base here is the base here. Okay? What's this called again? That's the exponent. Okay? It actually goes over here. What the exponent is, that's what we're trying to figure out, right? That's what's going to go over here. So if you can remember where those two things goes, guess where the a goes? The only place that's left, right? Guess what that's called? Good guess. Something with an A. It's called an argument. Why? I could make up a story and tell you they really fought about this and didn't know where everything was going to go, and they argued about it, and they just said, fine, we're going to call that an argument. But that would not be true. Okay? Why is it called an argument? I don't know. That's just what it's called. It's one of those definitions that I've just always accepted. Okay? If you want to go look it up, please do. Let me know. All right? So how do we read this? How do we read this right here? There are several different ways to say this. We're gonna write down the way I was taught to say it, but please understand it's not the only way. Fair enough? Log base B of A equals X. Now, a couple of years ago, Mrs. Prescott and I were talking about logarithms, and she was saying something about log of A, log of A, log of A, and I'm like, yeah, but what about the base? And she said, oh, it's just log of A base B. And I was like, oh. She said, what do you mean, oh? Well, you don't say it like that? And I said, I've always said log base B of A. And she said, oh. Neither one of them are right. Neither one of them are wrong. There's not one that's like more correct. Okay? I usually read it just left to right, log base B of A equals X. Okay? The way she was taught was log of A base B. Either way is fine. Fair enough? Why do we use logarithms? We use logarithms to solve exponential equations when the variable is in the exponent. Okay? You notice we didn't do that last unit, did we? Because there's no way to get that out of the exponent to solve for it until now. Okay? So one of the very, very basic things that I need you to be able to do is go from exponential form to logarithmic form, and go from logarithmic form back to exponential form. Okay? So look at problem A. 7 squared equals 49. First thing I want you to know about problem A is 7 squared is 49, isn't it? So this isn't just some random made up numbers. You can tell where they come from. 7 squared is 49. Okay? So we're not trying to solve anything here. We're just trying to rewrite this in exponential form. Okay? So I start with log. If it's going to be in logarithmic form, it's got to say log, right? Log base what? 7, because 7 is the base over here. Good. Of what? 49 equals 2. Done. Why? No. It's an okay question. This is the definition of logarithms from exponential to logarithmic form. I need you to be able to go from exponential to logarithmic form. I need you to be able to rewrite stuff like this, because this is one of the, again, I don't want to spoil all the surprises, but this is one of the ways that we're going to solve equations when there are variables in the exponents, is by putting them into logarithmic form, because that's going to put the exponent out here, and I can solve for that now. Okay, so right now I just need you to be able to go back and forth from logarithmic to exponential. Fair enough? Okay, so would you do this one? Could you do that one? Log base 3 of, let her. It's okay. Base 3 of 243.
I don't know how you got what it equals, so that's not
Look at the exponent.
5.
See the exponent right here? 2. Okay? No, you're right. I'm not having to figure that out right now. I'm just putting stuff where I know it goes. This is one of those things, Hannah, where like I have to teach you how to do it now just with stuff we already know with no variables to figure anything out, so that later when we start having variables, we can figure stuff out. Fair enough?
I didn't know where like the 3 was coming from.
Yeah, that's okay. That's okay. Okay? So what about C? Who's got C? Log base 6 of 1 over 36 equals negative 2. That's what she said. Is that right? Okay. Now, please notice that I'm being really very careful about my base. What am I doing with my base? It's really small and it's lower, right? It's small and it's down low, kind of like a wrapper, right? Okay? No, I just made that up. I don't know what that means really. Oh, this problem? Okay, yeah. What's the base? That's the base here. What's the answer? That's the argument. What's the exponent? That goes here. Okay? Does that make sense? Again, we're not trying to solve anything. We're not trying to prove anything. We're just trying to take it from exponential form to logarithmic form. We're just rewriting it. Okay? All right, what about D? Log base 9 of 1.5. Perfect. E? Log base 4 of x equals 9. Perfect. What about F? Log base 2 of 20 equals x. Log base 8 of 32 equals x. Can you go backwards? Prove it. 2 raised to the x power equals 64. What about I? X squared equals 64. J? 64 squared equals x. What about K? Dun dun dun. What's wrong with K? It doesn't have a base. Okay, I have to fix what you said, but that's okay, because you didn't know. I have to take a commercial break right up here. Okay? What is the exponent on that variable? 1. How do you know? It doesn't say. It's implied. It's understood, right? What's the multiplier on this 1? I mean on this x? How about if I just tell you the answer when I'm asking the question? It's a 1, right? How do you know that? It's implied. What kind of root am I taking here? The square root. Even though it doesn't have a little baby 2 right there, I still know it's a square root because it's implied, right? There's something called the common log. And when you have a common log, you don't have to write the base because it's understood. Tell me what you think it is. What would this look like if we rewrote it? The base that I don't know yet, squared equals 100. What number squared equals, okay? So we think maybe it might be 10. Well, look over at this one. Look at M. Something to the 4th power equals 10,000. Is that 10? So can we say with reasonable certainty that the common log base is 10? Yes. Yes, we can. If there's not a base written down, like let's rewrite L. How are we going to rewrite L? 10 to the negative 3rd equals, perfect, equals x. It didn't say a 10, but because it doesn't say a 10, it's implied, right? What about n? 10 to the x equals 1 over 10. We good so far? Okay. Look at A. It is now not just asking us to rewrite, although it is asking us to rewrite each equation, but then what? Solve. Okay? So can we rewrite these first of all? Go to exponential form for me. What does it say? 9 cubed equals x. What is 9 cubed? Gosh, I wish there was some sort of thing I could look up 9 cubed in.
Calculator.
Oh, calculator. My gosh, I don't know why I didn't think of that. X equals 729. What about B? Oh, wait, we're done, right? That's it. Yes, it is. We're done. So what about B? 3 to the x. 3 to what power equals 9? Done. Is it going to get harder? Okay, let's look at C. How do I rewrite this? X to the third equals. So this would be harder except for the fact that we just solved equations using exponents last unit. How do I get rid of this? Cube root, right? Cube root, cube root. What is the cube root of 64? 4. Done. It does get harder. Let me get there. Okay, what about D? 7 to the 4th equals X, okay. 2,401. Oh, that's definitely harder, right? Because the number is so much bigger, so that's definitely harder. Okay, so E is where it's harder, because there's no boxes. Guys, that's why E is harder, because there's no boxes. X to the 5 halves power equals 32. And I told you just a second ago, this would have been harder, except for the fact that we just got done solving equations like this. We know that we have to multiply both equations by the reciprocal of the exponent, the number, that's the exponent on the x. What is 32 to the 2/5 power? Make sure you raised it and not just multiplied it. 32 raised to the 2/5 power. 4. Remember, power, root. What's the 5th root of 32? What times what times what times what times what equals 32? 2. What's 2 squared? 4. Done. I didn't even use a calculator. I'm a genius. But so are you. Okay? What about F? Oh no, we panic because there's no base. Oh, it's 10. Oh, okay, okay. I should not panic then. What is 10 to the negative 4th? Oh my gosh, I wish we'd had a foldable that we could look up something about negative exponents. Oh my gosh. Negative exponents, if it's a to the negative n, it's 1 over a to the n, which would imply that this is really 1 over 10 to the 4th, right? Do we know what 10 to the 4th is? Oh, that's definitely harder because it's a fraction and a big number. Are you sensing my sarcasm? Good. So tell me about G. I mean, not that G. I'm talking about letter G on the paper. 9 to the x equals... Of all the ones on the page, this is one that I would be okay if you struggled just a tiny teensy bit with. Except we just talked about this problem. Tell me this. 9 to what power would give you 81? 2. What would cause it to be 1 over 81? A negative exponent. Okay? X equals negative 2. Perfect. What about H? 10 to the x power equals 10,000. 10 to what power equals 10,000? X equals 4. Done. You ready for I? I mean the letter I. 4 raised to the 0 power equals x. What does x equal? Oh my goodness. Because on our foldable we said... Wait, where is it? Do we put it on our foldable?
The 0 thing?
Yeah, the 0 thing.
I thought it was at the very back.
Yeah, it's not on mine. I don't know why.
The little blocks.
Oh yeah, here. Anything to the 0 power is what? 1. Oh look, x equals 1. What about J?
6 to 0.
Oh my gosh, 6 to the 0 equals x. What does x equal? Oh my gosh. Ooh, this one's much harder.
8 raised to the x equals what?
So what's x have to be? Oh my gosh.
1. 0.
What about this last one?
10 raised to x equals 1.
X equals? 0. Okay, for homework tonight, I need you to do the back. Okay, for homework tonight, I need you to do the back.
Awesome.